So this is the radio transmitter board I'll be using for the Hexacopter. There are three components on there right now. We have an RF link, a step-down converter, and the Arduino Nano with some header pins for the connectors, for the gimbal connectors to attach onto. And I've jumped all the relevant connections from the Arduino to the different pins and to different pins on the RF link and to the pins for the gimbals. This design is rather scrappy, so later on I'll be changing that. So currently let's talk a bit more about the key component, which is the RF link. So this is a breakout board for the nRF24L01 wireless transceiver chipset, which operates at around the 2.4 GHz band. It has an effective range of say 100 meters or so. It communicates with the Arduino via the serial peripheral interface, or SPI. So in order to avoid doing things all over again, I just picked up one of the libraries online that seemed to work well, and I've been using that ever since. So right now we have all the pins broken out from the NRF board to the Arduino, where we can see the SPI bus being used, especially on pins D11 and D12 with MOSI and MISO, which are the actual communication pins used in SPI. Then we have other pins such as D9 and D10 going to CE and SCN, which are chip selection pins that enable SPI communication. But first, I'd like to address the differences between these two NRF boards. One on the left here is a standard breakout board, which boasts all the features stated previously. But the one on the right here is the high-powered version of this board on the left. These two are basically the same, with the exception of this one having being able to handle higher loads and thus have a higher range. It has a far higher range than this one does. Where the one on the left here has a range of about 100 or so meters. This can easily double that range, and then some. Originally, I planned to use this one for my radio transmitter, but I kind of did some things wrongly, and it kind of produced some magic smoke, so I wouldn't be a sec. So right now, it isn't operable. So right now I'm forced to revert back to this standard version, and it still work fine. But until I get a new one of the higher powered versions, this will have to do. So currently this is the board produced by JLC PCB that I designed. It's a pretty simple board, as you saw from the schematics. There's nothing all that special about it, just the Arduino and the NRF board with some breakouts for the gimbal attachment points, and just a basic leaded PCB. Was about £2.50 for 5 of these, so it's pretty cheap, and arrived pretty expediently. About 4 days from DHL, but that was about with £17 worth of shipping. You can cost quite a bit less if you choose the longer haul shipping with about 3 weeks lead time. So all in all, it was a pretty good deal. So here is how the PCB looks like fully loaded, with the Arduino attached and the NRF board, as well as the logic level shifter at the back there, and a set of gimbals that I rescued from an old RC controller. So this is it for now. Stay tuned for next time and a full software breakdown. Thank you.